So for our last problem, I wanted to do one that I didn't kind of help you out step by step by putting part A, part B, part C, because you'll see some of these problems on your homework. So it says if you are dealt a 4-card deck from a shuffled 52-card deck, find the probability that all 4 are hearts. So first of all, you want to think, is this a combination or a permutation? So this turns out to be a combination. So the way in which you get the cards in your hand, it doesn't really matter the order in which you receive them. So combination because order doesn't matter. Now we want to find out what's the number of ways you could get dealt just any 4 random cards. So we're going to pick 4 cards from 52 cards and decide how much that's going to take. So we have 52 factorial over 52 minus 4 factorial times 4 factorial. 52 times 51 times 50 times 49 times 48 factorial. I stop at 48 factorial because 52 minus 4 is 48 factorial. And the 48 factorials divide out. So then I go to my calculator, 52 in parentheses times 51 times 50 times 49. Close that parenthesis. So I'm putting parentheses around the top. Then divide by, and then open another set of parentheses, 4 times 3 times 2 times 1, close that parentheses. And this turns out to be 270,725. Now if you had a calculator where you could just type 52 and use the combination function, you would also get the same value. Great. So those are the denominator. That's the different ways we could get any 4 cards. Now we're going to look for the numerator because we want 4 that are hearts. So let's look at the number of ways we could get 4 hearts. So we are picking 4 cards from the total number of hearts. Now, how many different hearts could we get? Well, we could have 13 total hearts in the deck of cards, and if we just want 4 of those 13, we're going to use the combination of 4 from 13. So 13 minus 4 factorial times 4 factorial. So 13 times 12 times 11 times 10 times 9 factorial over 9 factorial. I stop at 9 because 13 minus 4 is 9 factorial, and I want those two things to divide out nicely. So I go to my calculator, use the parentheses 13 times 12 times 11 times 10. Close that parentheses, divided by, open another set of parentheses, 4 times 3 times 2 times 1, close that parentheses, and that gets me 715. Again, if you had a calculator that has a combination on it, you could get the same thing just using that. Okay? So now I'm trying to find the probability of getting 4 hearts, which is going to be the number of ways I could get 4 hearts divided by the number of ways that I could get 4 cards, which is going to be 715 over the 270,725. Now I believe this reduces, so clearly because they both end in 5, I can divide both 715 divided by 5, and that's 143, and then 270,725 can also be divided by 5. 5, 4, 1, and I think I can divide again. This one happens to be, I can divide by 13. So I'm going to go ahead and do that. 143 divided by 13. That comes out to be 11. And 54,145 can also be divided by 13. It's 4,165. So the probability of getting 4 hearts is 11 out of 4,165. So if you're playing poker, this is going to help you figure out how likely or unlikely the next cards coming up might be. And this concludes our lesson on probability using the fundamental counting principle, permutations, and combinations.